Okay, this is Algebra 2 Year 2. This is the second review sheet that I handed out. It says review sheet number 1, but it's the second one that I handed out. So it says for the directions for 1 through 3 to find the probability of each event as a simplified fraction and a percent to the nearest 10. So we have to find the simplified fraction and the percent. So for number 1, it says a box contains 6 green, 5 yellow, and 3 purple balls. Find the probability of drawing a green ball in a single random draw. So first you're going to want to find the total number that we have in the box. So we have 6 green plus 5 yellow plus 3 purple. So we have 14 total. And we want to know probability that we're going to get a green one. So we have 6 green. So the 6 is going to go on the top. And that's going to be over the 14 total. We can simplify this fraction and it becomes 3/7. So over here our simplified fraction is 3/7. Now, to find the percentage, you're going to take this fraction, divide it, and you're going to get a decimal. You're going to get 0.429. That decimal you're going to multiply by 100. And that gives you a percentage of 42.9%. So your percentage is 42.9%. Number 2, when a number cube is rolled, the probability of finding a number less than 5 appears. So on a number cube, we have the numbers 1 through 6 as possibilities. So if we want the probability of rolling a number less than 5, how many numbers possible are less than 5? 4. 1, 2, 3, and 4. So we have 4 that are less than 5 over our total, which was 6. Reducing this fraction, we get 2/3. So our reduced fraction is 2/3. And then again, you'll punch this into your calculator, you'll get a decimal. You'll get 0.667, which translates to a 66.7% when you multiply the decimal by 100. Number 3. The probability that a card chosen at random from a standard deck is a king or an ace. So we know that there are a total of 52 cards in a standard deck. And there are 4 kings and 4 aces. So probability of king or ace equals the 4 plus 4 over the 52. So that's going to give you 8 over 52. And again, you can simplify this fraction that you get 2 over 13. So your simplified fraction answer is 2 over 13. And then again, to find the percent, you'll divide this out and you get 0.154, which translates to 15.4% when you multiply the decimal by 100. So those were probability problems. Now for number 4. It says find the number of possible passwords for 3 letters followed by 3 digits with only consonants and odd digits. So before we were using the whole alphabet and we were using all of the digits. Now it wants us to only use consonants and odd digits. So to find the number of consonants, we know that there are 26 letters in the alphabet. And we know that our vowels are A, E, I, O, and U, because it tells us that Y is to be considered a consonant. So we have 5 vowels, so that must mean that the other ones are all consonants. So we subtract this and you get 21 consonants. And then we also need to find out how many odd digits there are. So when we think about our digits, we have 0 through 9. So we have 1, 3, 5, 7, and 9 are all odd. So we have 5 odd digits that we can choose from. So this is a fundamental counting principle question. So we have 3 letters followed by 3 digits with the consonants and the odd digits. So for our letter choices, we have 21 choices for our 3 letters each time. And then we have 5 choices for our odd digits each time. So we're going to have 21 times 21 times 21 times 5 times 5 times 5. And that'll give us the number of possible passwords. So we end up getting 1,157,625 different passwords. And that again is the fundamental counting principle. Number 5. An ice cream shop has 21 flavors of ice cream, 7 toppings, and 8 mix-ins. How many different sundaes can the shop make? Now this question doesn't specify, but we're going to assume that you're only picking 1 flavor of ice cream, 1 topping, and 1 mix-in. So this goes back to the fundamental counting principle again. So we have 21 different ice cream flavors, and then we have 7 different choices for toppings, and then we're multiplying by the 8 different choices for mix-ins. So you have 21 times 7 times 8, and that gives you 1,176 different sundaes. Number 6. If one point is randomly selected from the points inside the rectangle shown below, find the probability that the point is in the circle. So this is our geometric probability again. And we need to remember that the area of a circle is pi r squared. So they don't give us our radius in this problem, but they do tell us that a side of this square is 12 centimeters. The circle goes from edge to edge. We know that the radius is half of the diameter, which would be a straight line all the way across the circle. So we know that the radius is half of this 12, so we get a radius of 6. So r equals 6. So we need to find the area of the circle. So that's going to be pi times the 6 squared. So you get 36 pi is the area of the circle. And then we need to find the total area. Now the total area is the total area of this square. So we're given that one side of the square is 12 centimeters. So a square, we know that all the sides are equal, and we know to find the area that it's side squared. So we have 12 squared will give us the total area of our square, and that equals 144. So to find the probability that our dart will land in the circle, we have the area of the circle, which was 36 pi, and we're dividing by the 144, which was our total area. And when we simplify this, we find a decimal of 0.785. So it wants us to find the probability. So you can either use this decimal, or it's better to write this as a percentage, which would be 78.5%. So there's a 78.5% chance that a dart thrown will land in the circle. Now 7 through 15. We're evaluating the expressions given. These can be punched into your calculator. So for number 7, we have 10 factorial over 4 factorial times 6 factorial. This gives us 210 when we punch it into our calculator. Number 8 is a probability problem. So I would like to see the fraction set up. So you should have 9 factorial over 9 minus 3 factorial. And when you punch that into your calculator, you should get 504. On the back, problem number 9 is a combination. So again, I would like to see the fraction set up. So you're going to have 7 factorial over 7 minus 3 factorial times 3 factorial. And then when you plug that into your calculator, you should get 35. For number 10, I would at least like you to simplify this so that you have 7 minus 3 factorial times 3 factorial divided by 2 factorial times 0 factorial. So 7 minus 3 is 4 factorial. Then it's times 3 factorial over 2 factorial, and it's multiplied by 0 factorial. 0 factorial is just 1. So 2 factorial times 1 is just 2 factorial. And then you can punch that into your calculator, and you'll get 72. Number 11. Number 11 says 10 people buy tickets for a raffle. First place wins $100, second place wins $50, and third place wins $10. How many different arrangements of first, second, and third place winners are possible? So we have 10 people that are buying tickets, and we're awarding first, second, and third place. This would be a combination or a permutation. So for this one, does order matter?
Yes.
Yes, order matters, because it matters if you win first, second, or third. You get a different money amount for whichever place you finish in, or win, or get drawn for. So, when order matters, what is that? Is that a combination or a permutation?
Permutation.
It's a permutation. So for this one, order matters. That means it's a permutation. So we're going to use the P notation, and we have 10 people, so you're going to have a 10 on the left. And we're choosing first, second, and third. So we're choosing 3 things. So you're going to have a 3 on the right-hand side. And again, I'd like to see the fraction set up. So you'd have 10 factorial over 10 minus 3 factorial. And when you plug that into your calculator, you should get 720. Number 12. In how many ways can 3 singers be selected from 5 who came in to audition? So we have 5 singers and we're choosing 3 of them. So this is also going to be a combination or a permutation. For number 12, does order matter? No, it doesn't matter which order we choose those 3 singers in, it's just we're choosing 3 singers. So is this a permutation or a combination? It's a combination. So order does not matter. So that tells us it's a combination. So we're going to use our C notation. So we have 5 singers, so you're going to have the 5 on the left-hand side. And we're choosing 3, so you'll have a 3 on the right-hand side. And again, setting up the fraction, we'll have 5 factorial over 5 minus 3 factorial times 3 factorial. When you plug that into your calculator, you should get 10. Number 13. In how many ways can 4 DVDs be borrowed from a collection of 25 DVDs? So this again is a permutation or a combination. It's a combination because it doesn't matter what order we choose our 4 DVDs from the 25. So again, order does not matter. So that tells us again that it's a combination. So using the C notation, we have 25 DVDs, we're choosing 4. So our fraction is going to be 25 factorial over 25 minus 4 factorial times 4 factorial. So this equals, when you punch that into your calculator, 12,650. Number 14. How many ways can 10 horses line up for a race? So this one, we're only given one number, our 10, and we're lining things up. So immediately we should be thinking that this is a factorial problem. Because we're going to have 10 horses, and once we've lined up 1, then we'll have 9, and so on until we're out of horses. So this is going to be 10 times 9 times 8 and so on until we get to 1. And this equals 10 factorial. And 10 factorial equals 3,628,800. And finally, number 15 is our expanding a binomial problem. And again, you can expand the binomial using Pascal's triangle or using the combination notation. Which way would you like me to show you? Pascal's triangle or combinations?
Combination.
Alright, so I'll show you using the combinations. So the combinations are going to become your coefficients. So we're taking this to the 4th power, so we have 4 and a 0 for our first combination. And remember, this notation means the C with the 4 and the 0, like that, is what that notation means. So then we're going to multiply by our first term in the binomial, which is the x, and it's raised to the 4th power. And then we have our 2y, which will be to the 0 power to start out with. And again, remember that the first term, the exponents will be decreasing. Second term, the exponents will be increasing. This is an addition, so all of our terms will be added. So our next combination is 4 and 1. X is to the 3rd now. 2y is to the 1. Four and 2 is your next combination. X squared, 2y squared. Your next combination is 4 and 3. X to the 1st, 2y cubed. And our last term, the coefficient for the combination is 4 with a 4. X to the 0, 2y to the 4th. So now we need to simplify our expanded binomial. So the first combination will give you a 1. So we have 1 times x to the 4th. 2y to the 0 is also 1. So I'm going to write it out so that we can see it better. And then we're going to add our next one. Our coefficient is a 4. So we have 4 times the x to the 3rd. And then we have 2y to the 1st, which is just 2y. Plus our next combination gives us a 6 times the x squared times 2y squared. So we have to distribute that squared to the 2 and to the y. So we have 2 squared is 4, and then y squared is what this term becomes. And then our next coefficient is a 4 times the x to the 1st, which is just x, times 2y to the 3rd. So again, we have to distribute that cube. So 2 cubed is 8, and then we have y cubed. And then our last term, the coefficient is 1. X x to the 1 is also 1. And then we have 2y to the 4th. 2 to the 4th is 16. And then we have y to the 4th when we distribute that 4th root. So now going back and multiplying our numbers through, we have 1 times x to the 4th, which is just x to the 4th, plus 4, and we have a 2 over here with our y, so we have 4 times 2 is 8, and we have our x cubed still, and our y. Our next term, we have a 6 and we also have a 4 here. So 6 times 4 is 24. X squared, y squared, because you still have your variables. Our next term, we have a 4 and we also have an 8. So 4 times 8 is 32 times the x and times the y cubed. And our last term, we have a 1 times a 1 times a 16. And then we have y to the 4th. So that is the simplified expanded binomial. And we're done.